This is the third in a series of videos to increase the level of knowledge you'd have got by watching my Edexcel IGCSE revision videos with the extra content covered in the Cambridge course that's not in the Edexcel course. The Cambridge course structure is in 5 topics. The Edexcel structure is in 7. This video is about the extra material in the waves topic that's not covered in the Edexcel waves topic. It's pretty much a straight swap except for 2 extra topics in the Cambridge course that I'll cover here. So let's look at those 2 waves topics. The first topic is lenses. You need to know about the action of a converging lens. That's a lens that brings parallel rays of light to a focus at the focal point. The focal point is on this line, the axis or the principal axis, and the focal point is a distance f, which is the focal length of the lens away from the center of the lens. For thin lenses, we assume that this distance is very small compared to this distance, and in fact we assume that the rays are only bent once by the lens at the line of action of the lens. Of course, in reality, the rays bend as they enter the lens and as they leave the lens, because they bend due to refraction. To find the position of an image, you need to apply at least 2 of these 3 simple rules. Firstly, a ray that is parallel to the principal axis bends when it reaches the lens, and so that it goes through the focal point. This ray then carries on going. The second rule is that a ray that passes through the center of a lens continues without being bent at all, and so that ray continues over here. The third rule, which you don't need to find the formation of this particular image, is that a ray that passes from the focal point to the lens then continues parallel to the principal axis. So here's how you use those to construct this image diagram. The object is this arrowhead. A is placed on the principal axis and B the arrowhead above the axis. You use an arrow so you can determine if the object and image are the right way up or inverted. The lens is over here where the rays pass through, and the principal axis, this dotted line in the center. This, A dash B dash, is the image. And you find its formation by applying 2 of these rules. So a ray parallel to the principal axis bends through the focal point, and a ray through the center of the lens doesn't bend. And these 2 rays from B meet here, and that's the position where you would draw B dashed, the arrowhead of the image. A dashed is formed on the principal axis because the object A was on the principal axis. So that's where you determine the position of the image. This is a real image because the rays really cross here, and you could put a screen here to collect the image, so the image would really display on the screen. It's a real image. A magnifying glass uses the lens to look at an object very close up. Your eye would need to be on this side of the diagram. So object here is closer than the focal point marked here with a dot. You draw 2 rays again, a parallel ray to the axis which bends through the focal point, and a ray that passes through the center. These 2 rays never meet. They're diverging. And that means that you'll never form a real image on this side of the screen. However, if you carry on those rays back to the left of the object, they're dotted here because they're virtual rays. They meet at a point, and that point is where the position of the virtual image would form. Your eye on this side of the lens seems to think these rays have arrived from this point. This is the origin that you see. In fact, of course, they've bent when they've got to the lens, and they've originated from the object here. So the image is upright in this case, but it's virtual and it's magnified. White light can be dispersed into different colours or different wavelengths of light. White light consists of many different wavelengths, and each wavelength corresponds to a different colour. Different colours have very slightly different refractive indexes in glass. This means that violet light is bent slightly more than red light when it enters glass, and again slightly more when it leaves glass. This spreads the light and white light into its constituent wavelengths. Monochromatic means light of a single colour or single wavelength. Monochromatic light would not be dispersed by a prism because there would be only one refractive index. So if this were red light passing into the prism, you would just get a single beam of light.